Right, these are the rules to determine if a function is the inverse of another function. So, in order for it to be true, then if you take what we think is the inverse and input it into the function, it will give us x for the domain of that inverse. And if you use the domain of that function, plugging it in into the inverse, it will also give you x. So that's all you have to do. So if we take a composite of f composed of g, and then we do a composite of g composed of f, if we end up with x, then they are inverses. If we don't end up with x, they are not inverses. So the first one, we're going to plug this into that function. So let's put a parenthesis, and we plug in g. And now we just have to simplify. And there you go. Check. So far it meets our first one. Now we got to check the other one. So we're going to plug f into g. So we're going to write out g and then substitute in f. So I've given g with a parenthesis, and then I plugged in f. And now we can simplify. So the parentheses, there's nothing to distribute, so we can just cancel those. Let's do this in blue, just to match. Cancel the 3, and there it is. So these are inverses of each other. That's all you have to do. These are inverses. All right, so try that one. Determine if those two are inverses. Hit pause and give them a shot. So after plugging each of them in, you should have gotten these answers. And if we go back, it's definitely not an inverse, because these are not just x. This is not an inverse. So g of x is not an inverse of f of x, and f of x is not an inverse of g of x. All right, so let's find out what it actually is. Because what's happening here is usually you would found the inverse and say this is it, and then we check it and it's wrong. So let's go back and see what the actual inverse is. So let's replace the f with y, and this will allow us to switch them to find our inverse. Solve for y. Divide by 2. And I'm going to separate them. So 1/2 x minus 2 equals y. So that should be our inverse. How do we know it's true? Well, we're going to do a composite of them. So we're going to go f composed of f inverse of x. And then we'll also do f inverse composed of f of x. Alright, so we're starting with our first function right here. 2 parenthesis plus 4. We'll plug it in. Alright, distribute. So that would be 2 over 2, which is 1, minus 4 plus 4, and there it is. Check one. Now let's check the other one. So we're going to plug it into this one, 1/2. So we're plugging it into the inverse on this one. We're plugging our function. So half of 2 is 1. Half of 4 is 2. And that gives us x as well. So yes, these are now inverses. This is correct. This is the actual inverse. We've just shown that it is. Alright, but why are we looking for x? Why is it each time that it has to be x in order for it to be an inverse? Well, let's look and see what's happening. Now that we have those two functions, I'm going to bring them down. F of x equals 2x plus 4, and then its inverse. Let's plug in some values and see what happens. So we need to find f inverse of 1 first. So if you notice, it's the f inverse, f inverse, f inverse of f. These are our composites that we've been showing. Okay? So let's try f inverse of 1. Would give us what? That's 1/2. Plug in a 1 minus 2. Half minus 2 is minus 3/2. Now we're going to take that minus 3/2 and plug it into our original function. Cancel. we get 1. Alright, now let's try it again with the other one. So f inverse of 4, it's 1/2 times 4 minus 2. That's 2 minus 2. Half of 4 is 2. That's 0. Now let's plug in 0. And we get 4. Now we're going to do f of 4. That's 2 times 4 plus 4. That's 8 plus 4. It's 12. So now f inverse of 12. That's 6 minus 2 is 4. Do you see what's happening? We plugged 1 into the composite of inverse of f, and we get 1. We plug in 4 into that same situation, we get 4. We plug in 4 into that similar situation, and we get 4. Do you notice each input that we start with is our final output? It's 1, we get 1. 4, we get 4. Plug in 4, we get 4. It's just a giant circle. That's all this is. Since they're opposites of each other, they're inverses, then when we plug it into f of x, we take any value x, plug it into f of x, right? The inverse will always take us right back. So it's just a circle. That's it. So if we can show that for any value that we plug into this little situation, it takes us right back to the start in both directions, then we know they're opposites of each other. We know they're inverses. Now you might be asking, why do we need to check both? Well, let's look at this one. Okay? So what I have is f composed of g of 4, and then g composed of f of negative 1. So if we plug in a 4, we should get out a 4. And we plug in a negative 1, we should get out a negative 1. Exactly. So we plug in g of 4. Gives us 2. So now we're going to plug into our f, which gives us 4. So we plug in 4, we get 4. So we would assume that that works every single time, right? Let's try f composed of g of x. So we're going to plug in the square root of x into it, which gives us x. And we already have a domain that x is greater than 0, so we would have an absolute value here, but we can get rid of it because x has to be greater than 0. It must be positive. That's our input. Now let's look at the other side. So we're saying, you know what, they're inverses. We're good, right? Well, let's check it out. So f of negative 1 give us 1. So if we plug in 1 into g, we get 1. That is not what inverses do. If you plug in a negative 1, if it's an inverse, we should get out a 1. And this is why we need to check both. Just because it works for one situation doesn't mean it's going to work for the other. You have to make sure it goes in both directions. We have it going this way, and we have it going backwards. Both directions have to give us an inverse. And the main reason is this. This is a quadratic, and this is this. This one is missing a domain on it. If you remember back when we did our one-to-one inverses right here, remember this? It had a domain. We're missing it. So we had that full quadratic, which makes it not an inverse. And it also doesn't check out as well. And that's it. So you have to check both to make sure that they work. Okay, and if you get an x, then it's an inverse, because if you input an x, you get out an x. They're opposites of each other.